Okay, now that we've factored our quadratics, we're going to move into graphing them. And we're going to look at 3 different forms. 2 of them we talked about in the last video, our standard form and our intercept form. So now we're going to add a third one. All right, but before we add that, we'll talk about the shape of our quadratic. So a quadratic, the shape is a U, right? So my parent function here, I bring this down, makes this U shape, and my parent function, or my most basic quadratic, is that x squared. Now this U shape has a name. We call it a parabola. Okay, every quadratic looks like this parabola here. It's just been transformed. It might be fatter, it might be skinnier, might be upside down. Okay, and there's a couple of different parts that you got to be able to find and know what they are on your quadratic graph. The first one is what we call the AOS, and that's our axis of symmetry. The axis of symmetry is what cuts your parabola in half, because if you notice, a U has symmetry. It has vertical symmetry, right? Right there at my y-axis cuts it in half, and it's the exact same on both sides. So for this case, should have used a different color, but my dotted line is how we label the axis of symmetry. It goes right down the middle. Okay, on that dotted line is our vertex. All right, so our vertex is the high or low point, or our max min, and it's right smack dab in the middle of that parabola. It's always on the axis of symmetry. So here, our vertex is right at the origin for our parent function. Okay, and then the a value. All 3 forms have that a value, and it does something a little different. It will always be the same a value, but it does something a little different than what the other points we're going to look at do. So the a value is always going to tell you which way it opens, so whether it opens up or opens down. All right, so if it's a positive a, your parabola opens up and it's a U shape, or like a touchdown. All right, if it's a negative a, it opens down and it's a mountain, right? It's an upside down U. So you can get that just by looking at the a value, and all 3 forms have that a value. But then the forms differ and they have different letters, all right? So to begin with, we have standard form, which we talked about when we factored, and that's the ax squared plus bx plus c. All right, so when I'm graphing in standard form, so to graph a parabola in general, I need 2 points. The first point that I need is a vertex. That's the most important point on your parabola. You have to have that vertex in order to graph your parabola. All right, so once I have the vertex, I just need one other point on either side because it's symmetrical. So if I find a point here, I know that I can reflect that over, and that's enough to give me a U. So I need 2 points, and one of them has to be the vertex. All right, so the vertex, right, in standard form, and I wrote it second, and I'll show you why in a second. It's a little more work to find it. So to find the vertex, I first have to find my axis of symmetry, because I know that it's on that axis of symmetry. My formula for the axis of symmetry is negative b over 2a. Okay, and b is talking about b in my standard form, and a is my a in standard form. So I do negative b over 2a. That's going to give me my axis of symmetry. That's going to give me this line that my vertex is on. Well, that's the x value of my vertex. So to find the vertex, I just have to plug in that axis of symmetry. So we're going to say and plug in, all right? The y-intercept I put first because that's the easiest thing to find. You can find that immediately, and your y-intercept is always 0, c. So your c value right there, right off the bat, that's your y-intercept. Okay, so graphing these, the first one, we have x squared minus 4x plus 1. All right, let me switch to a different color. So right off the bat, I'm going to say that this is my y-intercept. Okay, for number 2, that plus 5, that's my y-intercept. Easy peasy, done. Okay, let me draw an xy axis here and hope that I put enough points on it. Okay, so my axis of symmetry, or sorry, my y-intercept, I'm going to go ahead and put a point right there on my y-axis for my y-intercept. I'm going to come on this side, draw an xy axis, and this time it's up there at 5. So 1, 2, 3, 4, 5. All right, my axis of symmetry is negative b over 2a. So my a for the first one is a 1 because there's nothing in front there, so you can assume it's a 1. And my b is a negative 4. Make sure you keep the right sign. So to find the axis of symmetry, I do negative b over 2a, which is going to be negative 4 over 2 times 1. Right? Well, negative becomes positive, so this is going to end up being 4 over 2 times 1 is 2. 4 over 2 is 2. So that means that my axis of symmetry, right, it's always a vertical line, is going to be at 2. So I'm going to go to 2 and draw a vertical line. So you always go on your x-axis, right? So there's my axis of symmetry. If I want to find the axis of symmetry for the second one, right, negative b over 2a. My a for this one's a 3. And my b is a 6. So we've got negative 6 over 2 times 3. And that's negative 6 over 6, which is negative 1. So for this one, I'm going to go to negative 1 on the x-axis and put a dotted line. So there's my middle of the parabola. Somewhere on this parabola, or on this dotted line, is the vertex of my parabola. So to find the vertex, let's get a different color. We'll go purple. All right, so the vertex I know is on this dotted line for both of these. So to find the vertex, I'm going to take the 2 and plug it in. My vertex is going to be 2 comma something. The x value is always the y-intercept. So over here it's going to be negative 1 comma something. To find the something, we plug in. So I'm going to plug in 2 to my equation. So we have 2 squared minus 4 times 2 plus 1. Well, 2 squared is 4. 4 times 2, get minus 8, then plus 1. 4 minus 8 is negative 4, plus 1, so we get negative 3. So now my vertex is at 2, negative 3. All right. Over here, I can do the same thing. We have 3 times negative 1 squared plus 6 times negative 1 plus 5. Negative 1 squared, this number is always going to be positive. The x squared, because you square negative, it stays positive. So that's 1. So then 3 times 1 is 3. 6 times negative 1 is negative 6, and then plus 5. So 3 minus 6 is negative 3, plus 5, positive 2. So my vertex over here is at negative 1, 2. Okay, then I'm going to take that point. I need one more point to be able to get enough to know where to draw my u. So that y-intercept is what's going to help me. So my y-intercept is here. It's going to have the exact same point on the other side of my axis of symmetry because it's symmetrical. So I'm going to reflect that point over, and then I have enough to be able to draw my u. Okay, same thing over here. Here's my y-intercept. I'm going to reflect it over, and I have enough to draw my u. Now I know that seems like a lot of steps, and standard form is the longer one when it comes to graphing, but it's the same steps every time. Okay, start, find your y-intercept. Okay, then find your axis of symmetry, then plug that in to find your vertex and reflect your y-intercept over, and you have your parabola. Okay, the next one is our vertex form, which I think is the easiest form to graph in because it gives you what you need to know. Right, so vertex form is y equals a, that same a value, times x minus h squared plus k. So again, all these forms have an a, but instead of having b and c, vertex form has h and k. We call it vertex form because it gives us the vertex right off the bat. So my vertex is always h comma k. Right? Now, something special about h. H is always the opposite sign. Remember we talked about our parentheses. When you take something out of the parentheses, you change the sign. Well, H is in parentheses, so when I take it out to put it as a point, I take it out of my equation, I have to change the sign. All right, and then we're going to use the A value to figure out the rest. It's going to be kind of like a slope, and we'll talk about that one in a second. All right, so for the first one, I want to find my vertex. Let me draw my XY axis here. Okay, I'm going to get the vertex straight from the equation, and that vertex is going to be a positive 1, positive 2. H is opposite sign, K is the same sign. So I'm going to go to 1, 2, and I'm going to put a point. All right, now I know that this is also my axis of symmetry because it's got to go through that point, right? But I don't have to always have that on my graph. Okay, then I'm going to use my A value. So my A value is this 2. So that's like my slope to give me the first points, all right? So now if I go back to my parent function here, right? Now I did these points on purpose. I did actually graph our parent function using my graph paper, right? Because 1 squared is 1, 2 squared is 4, and it's the same on both sides. So for my initial point, I go up 1 over 1 to get that first point on both sides, all right? Or I can go up, well, we'll just do up 1 over 1, right? If I have a different A value, it's always that you go up A over 1 to get that first point. So when I come back to my graph here, my A value is a 2. So instead of going up 1 over 1 to get where that curve starts, I'm going to go up 2 over 1, right? But remember, it's not a line, it's a U, so there's half of my U. To get the other half, I just have to reflect that point over to the other side, and I get a skinnier U this time. All right, so that's it. For vertex form, you need to find your vertex and use the A value. Okay, so for this one, looks a little weird because I don't have parentheses, right? That means nothing's inside with the H, or H is 0. So here, my vertex is at 0, and then my K value -1. So 0, -1. All right, my A value is a -3. So that means instead of going up 3, right 1, I'm going to go down 3, right 1. So there's half of my U. And then I'm going to reflect that point over to get the other half. Okay, remember a negative means it's going to open down. It's going to be a mountain instead of a valley, or instead of a U. Okay, now another thing. If you have a form that doesn't have an H, you can consider this to be standard form or vertex form. I personally think vertex form is easier to graph. It's less work. So anytime I have just an x squared in there with no x term, I consider it to be vertex form. And our last one, which we talked about when we factored, is intercept form. So intercept form has that same A out front, and then x minus p, x minus q, and it's intercept form because it gives us the x-intercepts. So my x-intercepts are at p and q. Remember, opposite signs. Let's make a note of that. Opposite signs. All right, and then number 2 here, the second thing I have to find is that super important point, which is our vertex, Our vertex, you have to have the vertex. So for this one, it's a little different, right? So I'm going to start by graphing, and then I'm going to fill in how to find the axis of symmetry and the vertex, okay? So for the first one, let me draw my x and y axis here. To begin with, we're going to get our x-intercepts. I'm going to use pink. So I have one x-intercept at 1 and one x-intercept at -3. So I'm going to go to 1, -3. All right, so now my axis of symmetry is going to be right smack dab in the middle of those points because it's going to be symmetrical. So it's going to go in the middle. To figure out the middle of these 2 points, right, I can add them and divide by 2. So I could say this +1 plus the -3, right, is going to give me a -2 divided by 2 is going to give me that -1, right? So you could look at your graph once you're graphing and figure out the middle, or we do technically have an equation, and that's going to be add your intercepts and divide by 2. Once you have the AOS, just like we did in standard form, you got to plug in to find your vertex. All right, so I know that my axis of symmetry is at -1. So then that means I can plug in -1 to both of these x's and simplify, and that's going to tell me what my vertex is, right? Because I know my vertex is -1 something. So we're going to say -1 minus 1 times -1 plus 3. That's -2 times +2. So my vertex is at -1, -4. Oop, and I went a little bit too low when I was graphing. Right? Then you have your 3 points. And ba-bam. X-intercepts and vertex. Okay, so for the second one, looks a little weird again. Okay, the easy x-intercept to get is my 6. right? But this one looks weird, right? I don't know what this is. Just like when we factored, if I wanted to solve by factor, remember solution, root 0, x-intercept, they all mean the same thing. So if I want my x-intercept, I can solve. So whenever I solved, when we factored this way, I would say 2x equals 0, divide by 2, so then x equals 0. Anytime you have an x without any adding and subtracting, no matter what you multiply by, that means your root is going to be at 0. Okay, so let me get my xy axis going and hope that I leave myself enough room. All right, so I have an x-intercept at 0 and then at 6. 1, 2, 3, 4. Oh, daggone. Didn't draw it big enough. So 0, 6. Okay, that means that my axis of symmetry is halfway between, right? So I can look and I can say, okay, 1, 2, 3, 4, 5, 6. Half of that's going to be 3 away. So we can count. Or I can say 0 plus 6 divided by 2, which is 6 divided by 2, or 3. Either way works. And then I have to find my vertex. So to find the vertex, I take my axis of symmetry and you plug it in, because I know that I'm at 3 comma something. So to find the something, we plug in the x value. So 2 times 3 times 3 minus 6. Well, 2 times 3 is 6. 3 minus 6 is negative 3. Ooh, this is a big one. So then I get negative 18. Okay, my scale is way off, so I'm going to cheat. I'm going to say that this is negative 18. My apologies for making such a big number. All right, but really this is going to be a very, very long and skinny one. It's going to go way down to the bottom and come back up. Okay, but find your x-intercepts, find your vertex, and then you can graph.